So, thank you also for the introduction. So I will go straight to the presentation. And essentially, as you can see from the logo, I work not only in AI, but also on cyber security. And one of the tools that often we find in cybersecurity is Cyber Chef. Okay, Cyber Chef. It's from the UK agency for cybersecurity. It's a very nice tool that has a lot of stuff embedded in a web page, so you can try a lot of stuff without installing anything, and you can share easily the recipe by providing a link because everything is represented in the link. So ASP Chef, the idea is let's have a version of this Cyber Chef tuned for answer set programming for logic. And now it's a couple of years that we are working on this tool. We added a lot of stuff. And obviously, since everyone uses large language models, at some point we said, why we don't try to do something to include also large language models. So a nice thing of ASP Chef, we can pack everything in the URL. We can even store the URL easily on GitHub, and then we can retrieve the recipe with a short URL. So if you visit this link, aspchefalviano.net/s for short, LLMs for large language models, you will find a page with the documentation regarding the integration of LLMs in ASP Chef, plus a few pointers to, let's say, tutorial and example of usage. So feel free to explore. And the idea of this presentation somehow is to introduce this integration. So it's mainly set up as a tutorial, let's say, but let's see how much we can cover in 1 hour, okay? Now, I think that here I don't have to spend a lot of words about the structure of AI, but more or less we know that people that speaks about AI without really having an idea about AI actually are speaking about ChatGPT nowadays, right? So transformers, attention mechanism, and so on. And this is a part of machine learning, but we know that there is more, right? So there is the stuff that we work on KR or searching algorithms, formal reasoning, and so on, okay? Now, it's also true that if you speak with someone in the street, they very likely read some news about the fact that DeepSeek can reason as the thinking mechanism, and also OpenAI as thinking or reasoning models and so on. But it's not the same kind of reasoning we use in KR. So let's clarify this. But again, very likely in this room we are aware, but I want to reach some point. So let me give me the opportunity to state this. So usually the neural network systems are associated with the notion of parrots, okay? Because they have seen a lot of text, a lot of work, and they try to mimic, to repeat what they have learned. So like a parrot, without really reasoning about what they are speaking about. They just repeat. Now, when we have reasoning or thinking in a large language model, these are just buzzwords for a technique that technically is called chain of thought. The idea is we provide prompts to the large language model that ask to produce not just the answer, but before the answer to produce a sequence of steps that decompose the request. And then this sequence of steps is also analyzed by the large language model to produce the next words in the output, okay? And then the idea is that at some point, this sequence of talks will terminate and some answer will be provided. So this gives an opportunity to the LLM to somehow also cancel something that was produced or to ignore, let's say. And this is the result actually, right? So we go from a parrot to a parrot with ears, because now the parrot also can listen to the words he's gonna speak, he's gonna talk about. I mean, it's something, okay? It's already more than we have in several humans that just speak without even thinking or listening to what they are saying, but it's not completely what we usually refer as reasoning in AI. Let's give an example, okay? So let's say that we can use large language model for reasoning, complex reasoning task, okay? For example, suppose we want to address the largest click problem. So we are organizing a meeting, we want to have people have a lot of chit chat among them, and then we want to find a group of people that know each other. We have a list of pairs, let's say, of people that know each other, and then we ask to the large language model, can you identify this large component of persons that know each other mutually? Okay, so we can try to ask this to ChatGPT or a model like this, even with the reasoning like O3 mini high, whatever it is. Now the large language model is gonna reason for 27 seconds. Will provide a lot of stuff that we don't see because they want to keep the output clean. And then at some point is gonna provide an answer that essentially, at least in this example when I have done, is gonna state that we have to consider groups of 2 people because there is no trio, no triple of persons that know each other. Okay, but if I look the graph, I can see that there are several triangles in this graph. And we can do more or less the same with the DeepSeek. Okay, so in this case, we are selecting DeepSeek in Grok. There is the think section that we can see in this case. And then after several lines, 400 lines, at some point, we have the conclusion that it's enough to consider the person who has the largest number of connection, and that will be the largest click. Okay, so the model trivialized the problem. Okay, now we can simply scan the graph and take a conclusion. Okay, we find the most incident node, and then we select all the adjacent node including this one, and we have the answer. So in this case will be 6, but actually we can see that is not the case. Okay, so we cannot include all these persons because some of those pairs will not know each other. Now, obviously, we can take other problems like this that we are very confident we will not get the correct answer. Hamiltonian path. Okay, so we need to visit cities or locations in a map. We have the connection between cities. We would like to not go twice over the same city, and so on and so on. Okay, we know this problem. We are given the graph. We would like to ask to the models, can you give me this route that has this condition? We can ask to DeepSeek via Grok. And you see that here, the model is gonna think a bit, and then it's gonna provide a path that reaching G, the next move is gonna go in H, but actually our intention was to go to terminate on G. Okay, I don't know. Okay, the impression is that the computed path is not the one we were asking. And yeah, we can also go with ChatGPT. is gonna provide something, and actually, where is the problem? Okay, H, after H, we move to G, but there is no link from H to G. So also in this case is not correct. And yeah, to be honest, in this specific example, if I was specifying that the graph is directed, I was getting a correct path, Hamiltonian path. Okay, but we know even a broken clock is correct twice a day, right? And this will not make the approach sound and reliable. Why this is not possible? Yeah, because we know from complexity theory, okay, we are addressing problems that are NP-hard, and the transformer somehow runs in quadratic time with the attention mechanism, and there is a huge gap between these two. So even if it's correct on some small distances, can't be correct in general. So the idea of neurosymbolic AI is maybe we can combine the two approach, okay? The neuro approach, neural network, it's very good for several things. Let's take the neuro approach for those stuff, and let's move this the more formal stuff, the more reliable, the more complex thing with formal methods in a symbolic way. So the idea is that the parrot, anyhow, we like, is not bad at all. We want to use it. And the missing ingredient maybe is that we need reasoning, but not the implicit reasoning that we can observe in this large language model, where the model somehow has seen a lot of example and in a way or the other has some knowledge about a few processes and then can repeat this in an implicit way. We would like to have explicit reasoning. So what's the idea? We need rules, okay, that we can study, formalize, and so on, and then given a structured representation of the knowledge, we can couple this with deductive inference to draw some conclusion. Okay, so what we have done, what we usually do with knowledge representation systems. Now, what's the idea? Let's start with the parrot, okay, because the parrot is nice. So we can try this stuff with Grok. We need a free account, and then we have access to this playground, but we can also have access to the API server up to some limit. So what are the elements we are gonna play with? We can select a model, and there is a list that is gonna be updated at some point. We can specify the user message. This is what we usually provide to ChatGPT. It's our request. We can specify the system message. This is gonna control the tone of the assistant. So if we need an assistant that is more precise or more creative, or maybe we want to provide some context or some format that we expect in output, and stuff like this. Other element we have here is the temperature. That's just a nice word to hide randomness. Okay, so the idea is that with the temperature you control the creativity of the large language model, but on a technical level, this will introduce randomness in the output. Instead of selecting the most probable word at every step, there is a random selection among top K words. Okay, now if we want to be, if we want to have something that we can replicate, very likely we are going to set this temperature close to 0. And in Grok, this will go from 0 to 2. Okay, in OpenAI, it's different. It's from 0 to 1. I don't know. Okay, other server, Olama, is going to use from 0 to 1, but with a different meaning for 0. Anyhow, what's the idea that that we proposed. Okay, let's use the parrot for simple things. Okay, we don't want the parrot to address complex task. Okay, for the complex task we know how to do. Okay, the boring part can be the simple things. Okay, so why we don't ask the parrot, can you put this text in a structured form? Okay, because after I have the structured form, I know how to process the data. Okay, so let's ask this to the large language model. So we can go with prompts like this. Your answer must be in comma separated values. Just print the CSV, nothing else. Use the tab because later I want to process this data, so I must be somehow sure that the content has a specific format. In the user message, I can provide the graph in a, let's say, natural language writing. And then I'm gonna ask, can you give me the start point in the first line? In the second line, I would like to have the reach point. After that, give me the connection, one per line. Okay, maybe you want to specify the graph is the directed in this case, and so on and so on. Okay, so if we provide this content to Grok, we should have an answer like this. Okay, and maybe we can try. Let's see. So I have all the prompts on this recipe. And now we are approaching this. Okay, so I have this system message. I would like to go to the dev console here. I'm gonna put this system message and the user message. Okay, and yeah, let's try this. Okay, I obtained something here. Okay, what I do with this assistant message? Okay, these are the answer we have from the large language model. Okay, if I do other questions here, the chat completion is going to provide all the history of the chat. Now, this is a structured format, okay? It's a CSV. From this point, I can go with a formal system, okay? And now I will advertise ASP Chef. So the idea is in the input, I can provide something, but ASP Chef, you may imagine, is for ASP. So we expect relational form. Now, we can paste this content here, but we are going to get an error, okay? Why? Because this is not ASP valid syntax. So what we can do to bypass this limit is what was done for the emails. Okay, emails initially, you will just send text. At some point, someone said, I would like to send a file. No problem. Okay, let's encode the file in the text using a schema, base64. Okay, so this is what we are going to do now. We are going to press this button. This content is going to be base64 encoded and put inside the predicate. Now, this is going to be an attachment. Okay, an attachment for what? What you do when you receive an email with an attachment? You open the attachment with another program. Okay, so here is the same idea. Okay, what will be the program we are going to use? It depends on the attachment. In this case, is a comma separated value. So I'm going to go in the filter operation. I'm going to search for parse CSV. And now you see here, I'm setting a predicate that contains the attachment and was this predicate. I can specify the separator and I specify the output predicate. Now, all this content is going to be unpacked here in a relational form that I can now process with ASP. Okay. And what can I do to process this content? I will just add another ingredient to my recipe. Okay. So in this case, I have a set of facts. I would like to apply a small program. And then I would like to compute another model combining the facts we have at this point with the program we have at this point. So I don't have the time to type, I think. So I will copy again this. I will go to our nice recipe, search model. I will put the recipe, the program here, and down, you see that we have more facts here. Okay, so now this is a relational format that we better understand somehow as logician, right? So we have a node relation, we have a link relation, we have a start point, we have a target point. This predicate cell, very likely we don't need anymore. So we can exclude it by using select predicates with a no-code approach. So again, I'm gonna filter this operation, select predicates, and then I will keep all the predicates but cell. And you see the model is updated, and now I'm in a format from which we usually start in ASP, right? Usually we obtain this input representation with scripts and other approach. That can be a barrier for learners. The idea of ASP Chef is that you can put a few of these ingredients to avoid this scripting part. Nice. Let's move on, okay? Because ASP Chef comes with a lot of small utilities and tools. So we can, for example, provide a graphical representation of the graph. What's the idea? The idea is that we embedded a library, this JS, in particular the network module, that is specialized for producing graphs. How we do this embedding? We defined a template language for template system that is inspired by Mustache, very popular on the web, but we tune it for ASP. Okay, so in the original Mustache, you refer variables from a JSON or from a YAML file. What we do in Logic, we do conjunctive queries, right? So that's the idea. We are going to have a conjunctive query inside this Mustache, 2 times the curly brackets. The conjunctive query is going to be expanded with this content. That in this case is going to define a JSON object. This JSON object is going to be interpreted by this library, okay? So the mechanism is again this. We are going to do an attachment with encode. In the attached content, we are going to put Mustache query. And with the Mustache query, we are going to query the model we have in input. Okay, so in this case, you see, if there is a node that is not the starting or target node, we are gonna add a node to the node's object in the group 0. If it's the start node, it's gonna go in the group 1. If it's the target node, it's gonna go in the group 2. For every link, we are gonna introduce a link in our graph. And then there are a few other options. Okay, let's do this. Okay, now it's almost impossible that I will type this without an error, so it's very important that I will copy this time. Okay, I will put this content here. I will add, and again, this is gonna be an attachment, okay? You see, it's here. The ASP solver has no idea what to do with this, but the ASP Chef has a clear idea. So time and network, this JS network, is gonna take any attachment from this predicate. So let's put the attachment on this predicate, and it's gonna provide us a graph. Okay, so okay, now the graph yeah, seems to be the one we were expecting. A lot of connection on this side, no connection from H to G. Seems to be well interpreted. Okay, yeah, let's move on. Okay, so where is the real reasoning? Okay, yeah, that's the part. Okay, now we have a relational format that it's here, you see all these nodes here. What we do with this? Yeah, it's a Hamiltonian path. Okay, in ASP is a basic encoding that we often use to teach ASP. Okay, toy problems that we can address with a couple of lines. So what we are doing, we start from a node, we reach that node. Then if from that node we move to another node, we reach that other node. The next node we can guess with a choice rule, and we have to guess exactly one node from every reached node that is not the target. It's not possible to reach the same node twice, and we must reach every node. Okay, very classic encoding. Again, I'm gonna copy and paste because I will do mistakes otherwise. So search models. Search model is gonna take these facts plus whatever we put here. Okay, and it's gonna extend the program with some other facts maybe. Okay, so in particular, the one we are interested is next. Okay, so the answer was computed, but it's very ugly to read from this sequence of facts. Okay, it's very inconvenient. It's much better if we can do a graphical representation, for example. Okay, so let's do, because we have seen we can do this network. It's gonna be very similar to what we have done before. The only difference is that now we are putting in blue the nodes that are not in have not been selected, and those that have been selected in the Hamiltonian path are orange. Okay, we should obtain this representation. Okay, the steps are those we have done before. Okay, so the only difference is that we changed the line for the edge. So let's copy this content, and the trick is always the same. Okay, we need an attachment and an ingredient that interprets the attachment. So I'm gonna use encode for the attachment, and then I'm gonna put the network ingredient, and I'm gonna bind the two with the same predicate. And now you see, I now from this I can understand. Okay, here I have to read from A I go to B, from B to C, and so on. Here I can see from A to B, then C, then D, then E, H, from H, F, and then G. Okay, it's an understandable solution, okay? But suppose that we like parrots, okay? It's not that we suppose, we like parrots. People like parrots. We want to provide a parrot to the final user. So we would like to have an answer that is a text, okay? But must be something like human produced, not too many, not too much rigid in expressivity. Okay, because for otherwise will not appear like a parrot. How can we do this? Let's try to obtain a prompt. Okay, so for the parrot, we need a prompt so that the parrot can reply us. How can we obtain a prompt? We can use, again, the mustache approach. Okay, so I'm gonna define a template, visit the points in this order, and then I'm gonna do something with ASP to obtain a sequence like this, that it's gonna be more or less markdown. Okay, markdown, large language model are very good to read and write markdown, so it's not a bad idea. So let's try to obtain this text. Okay, so how can we do this? Yeah, first step, I need the attachment. The attachment I'm gonna put in the encode. And then what? I'm gonna ask to expand mustache query. This will take the attachment from this predicate, that it's the one we just added, and it's gonna replace the content by expanding the mustache. We can see the result without put encoded content, and here it is. Okay, so visit point in this order, blah, 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 blah. Okay, now it's a text, but not maybe, how to say, not parrot-like. Okay, we would like something more fluent, some text. So what we can do in this case, let's go back to the parrot that for us was the grok playground, and then we are gonna specify a different system message that we want to rephrase the text, the user request in a more natural form. And then we provide what we obtained, this list, okay? And then we should obtain this answer. Now, I'm going to reset this because I don't want to keep the history. I'm going to take the system message here that explains the role of the assistant. And then the user message is going to be, yeah, actually, this I can take also from here, okay? Should be the same. This content I'm going to put in there. Okay, go to point A, then B, followed by C, then D, and so on, blah, blah, blah. You see, a lot of different linking words to make the content more parrot-like. Okay, so more or less that's the idea. Okay, let's try to recap. We have a system. We started with a parrot, okay, and we asked it, can you structure this content? We obtained this from the assistant, okay. What we have done, we took this message from the assistant and we put in the input of ASP Chef. Okay, we have done this manually. After that, we made some data wrangling within ASP Chef to obtain a relational format. And from this point, we made the actual reasoning using ASP. We computed one solution, and then we made we set up somehow a prompt for the parrot, for grok, and this prompt then we copied in a different tool. Okay, now all the points with a blue arrow somehow are within the same system. The red arrow was manual. Okay, so we would like to remove these manual steps, right? Now, I think you already have the idea, right? So it's just another attachment. We are gonna use the mustache query for this. So we need API key. That's very good. This grok cloud provides access to their server via the API, and up to some limit, they don't ask anything. So for this, showcasing are perfect. The name of the key is not very important. What we really need is the API key itself. What we do with this API key, we need to register the API key in the browser. So do only in the browser you own. And for this, we can go to this endpoint. Let's see. Yeah, this endpoint you can reach clicking this question mark, where you will find a lot of other stuff. And then here there is large language models, LLMs. Here you have the documentation of the ingredient for the integration. And then you see there are getting started, register API, and call chat completion. Okay, so that's the yellow word. Okay, now you see it's gonna ask me, do you want to activate the key? Because I already registered the key. So I'm gonna say yes. Okay, the first time you have to put the key here, and then you have to click something in there. Enable for this session only, or you can register and enable. Okay, so if you register in the local storage, next time you will get this pop-up. Okay, now, if you see in the input, we have city render, okay, whatever, it's a fact, okay? What we do with this fact, we are gonna see, but if we move in the output, okay, so this is gonna traverse all the recipe, and then at some point we are gonna get something like this. The population is 35,000, Rende is a city and commune in the province of Cosenza, and blah, 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 okay, more facts. From where these facts come from? From the recipe. Let's see. Okay, yeah, by the way, if we ask for a different for a different city, Roccella, population is 7,000, Roccella is a comune in the province of Reggio Calabria, and so on and so on, okay? Again, from where this data come from? We interact with the large language model in a programmatic way. So what we need are a couple of elements. Okay, first of all, we need a small configuration. And in this recipe is this ingredient that you can find by filtering here, LLM config. Okay, that's the default config. That can go well for a lot of cases, but if you want to interact with a local server, Olama, or you want to interact with OpenAI, you can also select this and change the endpoint of the server. At the moment, we have only chat completion, so we can't generate image or do other stuff, maybe in the future. You can select the model that the server supports. If you want, you can select the temperature. For us, it's gonna be a percentage from 0 to 100, okay? So 0 means that we want to have repeatable answer. Where this configuration is gonna go, it will be attached to this predicate, okay? Attached for who? For some other ingredient of ASP Chef, okay? And what is this ingredient? Again, at the moment is chat completion. And what we want is to provide, where is the ingredient? Okay, chat completion, you see, is gonna take a configuration, and this is the one we defined here. Is gonna take messages. What are these messages? System, user, and assistant role. Okay, so you can put in this predicate, and then you are gonna use this format, message, then function name that must be system, user, or assistant, and then a text. Okay, so in this case, we are setting the system message, answer with a CSV only, use tab as separator, blah, blah, blah. The alternative is that you specify a different predicate, for example, for the user role, and then you can go with an attachment. Okay, so since the user message is usually bigger, you would like to have new lines, all this stuff, the encode is very likely the best option, and you can use the mustache query. So you see, in this case, we are asking for a specific city that we take from here. And then we are asking not just the population, but we are asking also 10 facts. Okay. Now, what this ingredient will do the interaction with the large language model. Is gonna get some output that we can see here. And then, yeah, it's a CSV. So we are gonna process as we have done before. We unpack in the cell predicate. Then the cell predicate we map to relations. We can filter, we can show them as a table, okay? And this is the result we are obtaining. Okay. Good. Okay, now Hamiltonian path, it's gonna be very, very similar, okay? And maybe I will go a couple of minutes on this, and then I think we can wrap. So Hamiltonian path, I'm gonna activate the key. So you see, we have start at point, blah, blah, blah. Okay, this is connected with this and so on and so on, okay? Then what we do to kill the red arrow, we need a configuration. That's the default. Then we specify the system message we would like to process to obtain a CSV. Then we would like to take the content that is currently attached to this predicate and put here in the prompt. And we want to add this other content, the instruction on how to structure the content. Now, we obtain essentially this prompt that is going to be used, is going to be transmitted to the large language model. The large language model is going to provide an answer in this predicate that is going to be a CSV. So we are going to unpack And then from this point are the ingredients we already seen. So we obtain a very nice relational format. We can show the graph. We can compute the Hamiltonian path. We can show the solution. We can set up a new prompt for the large language model. And if we want, we can directly call the large language model from ASP Chef. Okay, so with a different system message, we are going to provide this user message. This is going to provide the answer, the assistant answer in this output predicate. And this output predicate is going to be decoded. You see this button is active. It's going to be decoded in this point. Okay. Now, if you consider from this start point, all the elements are done within this recipe, and we obtain the answer. Okay, in the from parrot to parrot, let's say. Now, there are other ingredients for the other example we have seen, but I think let's wrap to leave some space for some question. So the idea is, at least my idea is, to use large language models for simple things. Okay, why? Because they are not reliable. Okay, you can't trust. It's also an issue for these simple things. If you have to leave them in an automated system, okay? Because as soon as you observe the way the input was structured, you will spot the error, and then you will change a bit the prompt. The problem is when you will have a larger instance, and also if you leave this in an automated system, okay, where you will not have this, how to say, you will not have the possibility to spot the mistake. But anyhow, for simple things, it's gonna work. So at least, how to say, should be more reliable than pretending to address stuff that we know cannot be solved in that time in general. And again, the idea is structuring the input, asking to reformulate the output somehow should not be too difficult for the large language model. It's a very syntactic task that should be somehow doable. For the reasoning is better if we do formal languages, okay? ASP, description logic, and other stuff like this. So I think I can stop at this point, and I'm ready for your questions, okay?
Okay, thank you. Let me just